Hi guys, this is usually fine. Today I'm just talking about the unsupervised machine learning. Yeah, in the clustering is the one of the unsupervised machine learning techniques uh, to play with data, and clustering is mainly used when the data is given without any label, any target. For example, the uh, product sold by customers or any anomalies from the data sets like unusual behaviors of data points in the data sets. That's we call as an unlabeled data, which can be a random one. Yeah. For this kind of data, we generally cluster use the clustering techniques, and where draw out the conclusion from the data. Uh, yeah, I have an keynotes in my notebooks. I just speak normally. I just speak shortly under the short noted topics. Yeah. Yeah, clustering is generally making the grouping the data with a similar natures, like just uh, consider imagine as in constellations of the constellations that the or thousands of stars in the space, and uh, just making the clusters of the closest stars. Uh, yeah, that is normally an analogy of the clustering. Uh, uh, let's get into the types of clustering. There are two types of clustering, that is hard clustering and soft clustering. In hard clustering, generally clustering is the technique of clustering in which individual data points is uh, included only in single clusters, like making a single clusters of the data. That's we call the hard clustering. And talking of the soft clustering means a single data point can lies under the different clusters, like uh, if you imagine the collection of stars, if you create the multiple, there are multiple stars in the sky, and they are considered there is in two clusters, and one is separate, one is single in one place, and which doesn't lie in both clusters. And now you can consider it as in you can uh, drop it into the first clusters. Let's say first cluster as in cluster A, and the second one is cluster B, and you can drop it into the clusters A and or in the B. So yeah, another simple analogy for the soft clustering is classifying the animals according to their habitat, like animals which live in land and water, for example crocodile. If we clusters the animals according to their habitat, like aquatic animals, making the clusters of aquatic animals, and making the clusters of the terrestrial animals, then the crocodile falls under the both clusters, like it lives in water also and in land also, so that this is a simple analogy for the soft clustering. uh, a single individual data point can fall under the different clusters. Yeah, that's all about soft clustering. Now let's dive into the type of clustering algorithms. Yeah, we have multiple. We have five. Yeah, we have all total five algorithms, and the first one is partitioning based clustering. In partitioning based clustering, I forgot what it was. How we partition data. Yeah, in partitioning based clustering, we generally define the number of clusters as in k, uh, which is notations for the number of clusters, and uh, we make we the data are clustered in the with nearest uh, distance, based on nearest distance, uh, and based on center. We calculate centroid and the data points which have the centroid less distance between dedicated data points, then it is clustered in that cluster, and so on for the other ones. Like for the different data points, if it lies or if it located were nearest to some data points, suppose let's say an A, and the B point is lying near to the A, then we cluster them in the same cluster, and so on for all the data points in the data sets. And another technique algorithms is hierarchical clustering. In hierarchical clustering, what we usually do is like we we make a big clusters from the small clusters, collection of clusters, and vice versa. Like we can think as we generally understands hierarchical as an tree structure, and in same way in reverse order it works like I spoke previously. uh, collecting making the clusters, we can make the big clusters from the branches one. Like if we have the cluster if we have the clusters of two data points, let's say x and y, then and another uh, subgroup, let's say subgroup of a and b, and we can make the universal set of x, y, and ab, uh, and and opposite same as opposite. You can what uh, you can you can deconstruct the universal set into multiple subsets. You can do on that way. That's what we call as an hierarchical clustering. And another we have the density based clustering. In the density based clustering, generally we clustered based on the density of the clusters. Like uh, at certain point, if your value of x is if the data is mainly concentrated at certain points, let's talk about the coordinate one. Like if the density of data is high at the 9 comma 10 at the in the 2D plot, multiple data points lies around the 9 comma 10 coordinate. Then in this on the basis of these concepts, this core idea, we generally clusters the data uh, based on density. This is the core idea about the density based clustering. And another we have the distribution based clustering. In it is same as an density, but we generally use the probability in the distribution based clustering. Like firstly we first of all we uh, calculate the probability of the data points for which it falls under the clusters A, and we set like a boundary, yeah, cutoff value, like if the probability is higher than x, then we bring it to the I mean we add into the clusters, these clusters, and if not, then we'll add into the another one. In such a way we work in the distribution based clustering. And last algorithm of clustering, type of clustering, is grid based clustering. Generally I am not more clear about it. Okay, let me see the note. What is it? Divide into data space into a discrete space called grid. Then the density of data in each group is used to classify it as a noise or clusters. Divide the data space into the discrete space called grids. Then grouped based on neighboring location to form the region of clusters and empty regions. Uh, discrete. I am not clear about discrete grids. Like what actually discrete grid is. Dense data point. Okay, we'll leave it for now, and let's talk about the applications of clustering. Like we use the clustering in different field. Clustering is popular unsupervised learning algorithms, and its applications are like customer segmentation. We can separate, we can cluster the customers based on their purchase, location, and activity. Like uh, a seller, it is much more helpful for the seller to optimize the product accordingly, uh, and recommend new products for the uh, customers. And another we have anomaly detection. That is what actually anomaly is uh, it is like unusual data, or the chances of occurrence of this data, this kind of data is low. For such kind of data points we generally call as an denote with an analogy term. Sorry, I don't, I mean anomaly term. And another major, the anomaly is generally used in the anomaly detection is generally used in the transactions, like uh, yeah, in banking sectors, and in fraud detections. And that's an application of clustering. Another we have data analysis. We data analysis In the data analysis, we can use the clustering is if we have an high dimensional data sets, and we can't plot the data more than in 3D space. For that we generally clusters we make the clusters, and detect and analyze the data, and We have PCA in the clustering also. The PCA is generally a principal components analysis where we can reduce the dimensions of the data sets. And yeah, that's what an application of clustering. Another is image segmentation. Yeah, in image segmentation, how we can use clustering is we can make the clusters of similar colors. We can use while compressing the image, we use the clustering technique, like we calculate the centroid of the colors, which is as clusters, and we pass the centroid value, and we compress the image quality, and as same for the, like opposite for the improving the quality of the image, like from the centroid or from the value of the original image, we generally extrapolate the data. And I think we I am not more clear about extrapolating, but in my opinion, we just extrapolate from the single color, and then we improve the quality of an image. Yeah, that's all about the clustering techniques, type of clustering, and algorithms and applications. Yeah, here's the end of the video. Thank you.